Now let's wade through some more of these examples of pointer arithmetic. So I've mentioned we have to deal with the painful process of more precedence and order of operations things, so these long expression questions, because now we have to understand how the pointer operators interact with operators like plus plus and minus minus and plus equals and so on. So I feel like the one that tends to be the most challenging is when you see plus plus used adjacent to the star. And here we've got brackets, and we should know from before midterm 1 that the brackets are often optional and that there's a defined order of operations, which we call precedence, that determines which thing happens first. But here we have brackets, so let's try going through this. And our goal is to determine the output of the code. So I've set everything up. I've set up my diagram to already contain my array Q and a pointer, which is initialized to Q sub 2. And now I say int z equals star p all plus plus. So what this is saying is dereference the pointer p, add 1 to wherever you end up, store it back into that location, and then send back the old value of that location. And so keep in mind that what the thing actually being incremented is the endpoint of star p. Z is just getting what comes out of this expression. So we have to evaluate the expression in layers like we normally would. So the first layer, what is the value of star p? Well, star p brings us to this location here. So I'm going to actually cross this expression out and write in the actual, this is Q sub 2. All right. So I'm really saying Q sub 2 plus plus. And we know from before midterm 1 how to deal with that plus plus operator on the right-hand side. So Q sub 2 plus plus says increment the value here, so this is now 31, and then send back the old value of the variable. I guess I'll just cross this out and write in the old value was 30. And so the value of z gets set to 30. Okay, so what's the output of this? Well, the output would be the value of z and the value of star p. So what's the value of z? Well, it's 30. What's the value of star p? It's 31. All right. So just like before, really what we're doing when we use the plus plus operator is no different than what it was before midterm 1. The difference is we have to, before using plus plus, go find the location that we're incrementing, and that it requires dereferencing a pointer using star p. Notice that the value of p wasn't changed by this operation. The thing p points to was, but the value of p itself, where the arrow is pointing, that isn't changed. And that shouldn't surprise us, because the plus plus operator is the only thing in this statement that could possibly have modified p, but it didn't, because the thing the plus plus operator was operating on was the result of following an arrow, not p itself. Okay, so here's the next one. And I copied and pasted in my initial diagram just like before. Here I'm using the plus plus, the pre-increment operator, so I'm using it on the left-hand side. But otherwise, I'm still dereferencing my pointer before I'm incrementing. So first, I figure out what's happening inside the bracket. So star p, well, that would be start at p, follow an arrow, and just like before, that ends up being q sub 2. All right, and then I'm actually now executing plus plus of q sub 2, so I increment this value, and I send back the new value of q sub 2, which is 31. So the value of z ends up being 31. Okay, so my output is then z and star p, start at p, follow an arrow, and 31, 31. Okay, so what about this one? Now, this is going to require you to take a look at your precedence table, because it turns out that without the brackets, this thing, the post-increment operator, has higher precedence than the star. And that means the imaginary brackets go here. So that's significant. And I guarantee you there will be a question on a midterm or final exam. There won't be tons of them, but there will be a question that requires you to employ precedence and pointers at the same time. Okay, so I've installed my imaginary brackets. They go like this. I do p++ first, and then working with what comes back, I dereference. Okay, so p++, that's going to modify my pointer p. Okay, so to modify my pointer p++, what that's saying is increment the value of p. Here's the old value. It was a pointer to q sub 2. Increment the value of p, so p now points to q sub 3, but then send back the old value. Okay, so I send back the old value, which was an arrow pointing at q sub 2. So what I'm actually executing now is star of arrow pointing at q sub 2. In other words, create an arrow pointing at q sub 2 and then follow that arrow. So I create an arrow pointing at, a sort of a notional arrow pointing at q sub 2. Okay, there it is. And then I follow that arrow, which gives me the value 30. Okay, so the value of z will now be set to 30. And I need a place to write my output. There it is. And my output will be, well, what's the value of z? It's 30. What's the value of star p? Start at p, follow an arrow. Always follow that arrow because the value of p was modified in a strange way, so we shouldn't assume p still points to element 2. Start at p, follow an arrow, and we get the value 40. All right. So, and there are, of course, a few other variations of this. So one variation would be, what if I use the pre-increment operator here? What if I manipulate where I was putting the brackets? And I could have added the brackets explicitly, but I didn't have to because in this case, precedence dictates the imaginary brackets would go where they did. So here are a few other exercises to go through. This is a hard one to run the code for because some of the values we're going to be talking about are can't easily be printed out. But let's try going through it. So I've begun by constructing my my first three values here. So a float called f, a float called g, and an array of type float. And then things are going to get weird. So the next thing is I would like to have an array called p apparently, but the array is of element type float star. And the natural question is, wait, can I create an array of element type float star? And the answer is absolutely I can. I can make an array of any type. Okay, so let's draw this on our diagram. Okay, so I'm going to put it over here. This is going to get pretty nasty looking. So float star array, and there it is, and its name is p. Okay, so we'll draw the usual thing. It has two elements, element 0 and element 1. We'll make the array a little bit better looking than that. There we go. And there's element 0, there's element 1. Okay, the first element is arrow pointing at f. Okay, so that means it's this. The second element is arrow pointing at h sub 2. So let's check our types. The element type of p is float star. So what goes in this box has to be a float star. What is the type of arrow pointing at h sub 2? Okay, well here's h, 0, 1, 2. Okay, so there's h sub 2, it's a float. So an arrow pointing at h sub 2 would be a float star. But p is allowed to contain float stars, so this is valid. All right. Okay, so next thing, float star q equals p sub 1. This is a really, there's a lot of nuance to this. It's easy to get tripped up by this. So float star q equals p sub 1. We'll draw it on our diagram first. So q is a float star. There it is. P sub 1. Okay, so let's validate the types. What is the type of p sub 1? P sub 1 is an element of this array of float star, which means that p sub 1 itself must be of type float star. Okay, so this here is a float star. And q is a float star. So the types do match up. And the reason why it's important to validate that here is because it's really tempting to accidentally do something like put an arrow pointing at p sub 1 inside of q. But that's not what we're saying. We're not saying create any arrows here. There's no ampersand. We're saying copy the value of p sub 1. Okay, the value of p sub 1 is this arrow. So we copy that into q. And we already checked the types do line up, so that works. And then I'm gonna cheat a little bit here. I'm gonna put r in the middle. Just jam it right there. R is also a float star, and it equals arrow pointing at g. And we're past the point now where we should be able to validate this part in our heads. We know that g is a float, so r being a float star can contain an arrow pointing at g. All right, we're still not done. We now have to create another array called z. Okay, so here's z down here. And z's element type is float star star. You can verify to yourself that yes, we can create arrays of element type float star star. And z's values are z's going to have three values, three elements. Element 0, 1, and 2. And they're going to be arrow pointing at q. So every element of z is of type float star star. Okay, so what is the type of arrow pointing at q? Well, q is a float star. So an arrow pointing at q is a float star star. So this is valid. So we've got this. The next element is arrow pointing at r. Oh, yuck. Okay, so arrow pointing at r is also a float star star. R is a float star. Arrow pointing at r would be a float star star. How am I going to get away with this? Okay, I'm so sorry. There we go. Ooh. And then finally, the third element of z is arrow pointing at p sub 0. Okay, oh boy, I've put everything in the wrong order here. P sub 0 is an element of p. The elements of p are of type float star. So if I take an arrow pointing at p sub 0, that will be a float star star. So I draw that in. So arrow pointing at p sub 0. This is not going to be fun. Oh boy. I'm so sorry about that. There we go. Arrow pointing at p sub 0. And now we have to go through these expression exercises. So the question here is, what is the value and what is the type of each of these things? And some of the answers for the value aren't going to be something that we could just print out. We'll have to write in what they actually mean. Okay, so first one. What is star p sub 0? Okay, so what is p sub 0? That's this box here, p sub 0. Star p sub 0 would be start here, follow an arrow. Well, the value there is 6, and the type is float. All right. Okay, and then there's this. Star of p sub 1 all plus plus. Okay, and we'll just have to hack away at that. So what's p sub 1? P sub 1 is this box. What's star of p sub 1? Star of p sub 1 is up here. It's this value 5.5. Okay, so star p sub 1 would actually be h sub 2. So I'll just scribble that in over here. Star of p sub 1 plus plus. Well, we know that star of p sub 1 takes us to h sub 2. All right, so I take h sub 2, I add 1 to it, and I send back the old value. Okay, so I add 1 to it, so now it's 6.5, but what comes out of the expression is the old value of h sub 2, which is 5.5. Now that's nasty. And the type of that, well, let's see, it's actually a float. For the sake of the exercise, I'm using the plus plus operator in a bit of a naughty way here. We really shouldn't be using plus plus on floats. Okay, so then let's dispose of this. Okay, so now we get a couple of easier ones. What is the value and type of star q? Okay, so we go find q. There it is. So star q would be, the value is 6.5. Okay. And the type, it's an element of an array of element type floats, so that means it is also a float. All right, and what's the value and type of star r? Okay, same story. So started our follow an arrow. I get the value 10.5, and that's a float. And then finally, what are the values and types of star star z sub 1? Okay, so z sub 1, that's this thing. If I start here and I follow an arrow, and then I follow an arrow, I get to 10.5, and that has type float. Now, it's worth considering, you could easily be asked a question like, what is the type of star z? Or what is the type of q? It's hard to know how to write the value of that, but it's perfectly valid for me to ask you a question like, what is the type of star z? So star z would be start at z, follow an arrow, and that takes me to a float star star. It takes me to the first element of z. We know that every element of z is of type float star star, so star z would have type float star star. And it is completely legitimate on an exam for me to ask you questions where the final value and type isn't necessarily an int or a float. It's some kind of pointer or arrow or whatever else. You especially should be able to answer what is the type of that. So if I ask you a question like, what is the type of z sub 2? Well, you'd go to z sub 2. Okay, that's float star star. If I ask you, what is the type of star of z sub 2? Okay, so go to z sub 2, follow one arrow. Okay, the type of this would be, it's an element of p, and an element of p has type float star, so the type of this would be float star. So we should be able to understand the types of things even if they're halfway down our diagram and we don't really know, like, how would I print out this value? Well, I don't know. You could try printing out pointers if you want. You'll discover it just prints out as some long number. But we should still know what the type of each thing is, even if it's some strange synthetic pointer type.